Good evening.
There we go. I had to click through.
We made it. There's just two of us. Oh, somebody in the waiting room. I don't recognise that.
Martin will be on his way. I just called him. There was an invite was sent out with a workcast link on, so I had that open.
I don't know. Was that what you sent to one of the guys today?
Yeah, because it's in my calendar. I don't know how it's got there, who's forwarded it on to me, but it's in my calendar for this time, 5 till 7, or 5 till 8. Sorry, who's it sent out by?
I looked at the
someone called Natalie sent it out.
Natalie, I didn't recognise the document at all.
Yeah, no, I didn't.
We just have straightforward Zoom, and we don't have any registration because it's too many complications. So
yes,
to join the meeting.
Yeah, no, that's why. So I'm in here now. I've got the Zoom on.
Right. So what we'll do then when we get going, I'll introduce everything.
Who's can you see who's in the waiting room?
There's 2 people at the minute who we're expecting. I've got Dr. Anthony Cash. I don't know who he is. No. And Martin's the secretary. I'll let him in.
Yeah. Keep an eye out for Liam Purcell and Chris Beals as well.
Yeah.
As well as Tom and James.
So then what I'll do hi Martin.
Hi, Dave.
I'll hand it over to you, Tom, to conduct the presentation competition.
Yep.
And I'll mute everybody, and then I'll unmute you, and then unmute the speakers.
Perfect.
It's not so bad on IMechE. It's when you get all these other meetings where you get all these old folks and they never mute, and the missus comes in and gives them a cup of tea, and they start talking about IKEA and.
I don't know. We had that last time, I think, on the last IMechE one, the one that Gareth did.
I mean, as long as people mute themselves, we can ask them to, but a lot of people don't have to do it, I don't think.
We were both on the annual, the luncheon, the virtual luncheon, when Felix was giving his address, and there was a separate room, but they could be heard in the main chat. So there was probably about 150 people on this meeting, and 5 people having a private conversation, thinking that they couldn't be heard in like a separate room, but they couldn't hear Felix, and it was a disaster.
Was it embarrassing?
Yes. I'll just check as well. I'll just see Martin has.
Chris Beals is in the meeting room.
An updated link out. Let's see what ends in 09.
Is that Chris? You know him better than I.
Is he in? Yeah, there he is. Yeah, you've got to click your have I sent the wrong T09? I've sent them that one, haven't I?
Hi guys.
Hi Chris.
Hello. Just checking we've got the right link sent. Oh yeah, they've got the right link. Participants. So Chris, have you done one of these? Have you presented on one of these before?
On what?
A Future of Rail presentation.
Never done it. No.
Okay.
So, I'll be interested to see.
You're representing the YRP in this capacity. Good.
You've done a Zoom before, have you, Chris?
Yeah, I've been.
Share screen and all that.
Yeah.
Yeah. Okay.
You're on mute, Martin.
Just for my just for my understanding, I'm not actually presenting tonight.
No, you don't need to share your screen. That's what I was trying to say.
My mistake.
Hi, Chris. Sorry, I put myself on mute because Jason just rang. Jason Groombridge has offered his apologies, Dave.
Well, that's novel.
Be careful what you're saying. There are 2 people on the call.
He's on site at the minute. He's down in Gemini on his way to London. We've just had his quarterly address before this.
Sorry, Chris, I was getting you mixed up with one of the presenters when I was talking about the Zoom.
That's all right. Yeah, the blood pressure just spiked a bit there for a second, but it's all good now.
You just look too young. That's what it is, Chris.
Yeah, shouldn't have shaved this morning.
So we should have Liam Purcell join in.
As a judge.
Yeah.
Yeah. I'm catching up with the last 3 days' emails on this laptop.
So, who are the presenters tonight then? Is it Tom?
James Morrison is one.
James Morrison. And I plan on James first, then Thomas, because that's the order it is on the poster. So why not change anything? I've not done, being two presenters, I've not done a structured timed agenda like there was last year. Sort of 5 minutes chat, 15-minute presentation, 10-minute question, 15-minute presentation, 10 minutes of question, then hand over to Dave.
Yeah. And at that point, we will drop off the call, and there's a separate Teams call that I've got set up with Chris and with Liam, and we'll have our judges' deliberations. We'll try and keep that as quick as we can, because Dave's not going to talk for that long, I don't think. So sort of within 10 minutes, hopefully, we'll have a decision.
Right.
Does that sound all right, Dave? Is 10 minutes long enough for you? Is 10 minutes too long?
For the AGM? Yeah, it's only going to be me reviewing the year, which isn't the best year we've ever had. No reflection on the chairman, of course. Yeah, I end on a positive note anyway. You know, what's happened in the last week has probably added to that positivity. So we can be confident that if we can find somewhere, we can go back to face-to-face by September.
Yeah, that would be good, wouldn't it?
Now, Liam's coming in.
Perfect. Thank you for who's this, Liam. Much appreciated.
Hello. Evening,
Hi, Liam.
Hello.
Sorry about the confusion with Zoom links. Hopefully you obviously made it through that, so that's good.
I was all right. I was just taking a phone call from someone who stood at the waterfall trying to get in.
Another one. We had one the other week, didn't we?
We did.
Well, the website's up to date. The website says they're all virtual, and they're all the links on them all. So I can't see why people should not stay at home and keep warm. Perhaps they wanted a nice drink of expensive lager. I don't know.
Okay.
We got an idea of the topics tonight.
Yes, we've got. James is presenting on mitigation against ice on overhead equipment, and Thomas is introducing 3D printing to rail operators.
Okay.
Both sound very interesting. Quite not something I've heard before from either.
I've already declared a potential conflict because James has been working on a project for me, but I think I can still be a fair judge.
I was hoping to have some from Porterbrook so Chris could be biased as well, but they've all played the COVID excuse and said, "Oh, we can't present on anything because of COVID." And I quite candidly said in the middle of one of our graduate meetings, "Well, have you justified your job for the past 12 months?" which was quite cruel, but fair.
Don't really get that excuse.
No, everyone that I asked from internally, and quite a lot of people have said, "Oh, I don't feel I've got something to present on because of COVID. I'd rather present next year."
Well, there's plenty of stuff that's been happening in the business. So.
Yeah, I know. But, it took me until I was in my 4th year of employment to present at one of these, so I kind of get the excuses because I made excuses for 3 years and then finally caved in the 4th. So.
Well, I thought the reason there were only 2 candidates was because people hadn't been actually working physically. You know, they've been sat at home. But...
No, a lot of people. There's a reluctance to present, I think, because partly the sort of people don't like presenting, and I know. People I've asked, they said, "Oh, I'd love to, but maybe next year," or "I don't feel I've got a strong enough topic." And I used your example that you, Dave, gave, where a winner a few years ago literally just changed a bolt or did something very, very simple, but it's what they did and it fixed the problem, and that won. And you can try as hard as you can, even dangle. I even said you'll guaranteed to get some money, probably at least 25, 50 quid, by nature of there only being 3 people on the call, and still people wouldn't do a 10-minute presentation for 25 quid.
Just looking at the judging criteria as well, there's only, out of the 20 marks, I think it is, there's 5 marks for actual content. So, you could come and present on something that you might think is really basic, but if you deliver it really well, then you have a chance.
It was like throwing myself against a brick wall. I know Martin and Dave know that I've been trying. I know everyone who's been involved has been trying to get people involved, pass it on to other members, and so I appreciate yourself, Liam.
We have the same at PWI. We used to run a young members presentation competition, but we gave it up a few years ago. Since
I'm worried we haven't got either of the 2 candidates in the waiting room yet. We've only got 5 minutes.
They may be joining.
Do you want to run this link or a different link?
They got the link, didn't they, Tom? Because
I sent it on to them.
Yeah.
Is it the same link as this? So I can forward it to James.
Yeah, it's the same call. Yeah, no, as long as you send the right one and not the one for the March meeting, which I think I sent to you, Chris, and to Liam. Sorry for that.
All right. Probably try and find the other guy as well.
I think the lesson, Tom, for next year is to actually maybe start a bit earlier. And I appreciate, you only came onto the committee in January, didn't you? So
it's a short turnaround, but still. 10-minute presentation. How long does it take to knock one of those up on something done? Yeah. But very appreciative for the 2 that have taken part, and hopefully they'll
fate.
Well, having this on your CNG application, I said to everyone, having this on your CNG application can only do you good.
James in. James has just joined. But he's shy. He's got his video off.
He's realised we're all wearing shirts and has quickly gone to change out of it. As I do on many occasions. Leave my camera off to see what the dress code is.
No, sorry, I was trying to fiddle with my settings on the browser to allow for my camera usage.
Thank you for joining, James, and thank you for presenting. It's much appreciated.
No problem.
Justin, make sure.
How's everyone doing this evening?
Chartership application.
Pardon, what was that? Sorry.
I was going to say, make sure you put this on. We were just discussing before you joined. This will do wonders for a chartership application.
I haven't even looked into that yet. It's still early doors for me.
What stage are you at then, James?
So I'm doing my year in industry currently. So sort of still not graduated. Once I get over that hurdle. We'll start looking at chartership.
Look now. So I did a year at Worcester Bosch, which wasn't an IMechE course. And when I started at Porterbrook, because I got a year's previous work that's unaccredited, I could 6 months off my chartership application.
Oh, wow.
So,
okay, I will definitely do that. I'll put that on my list of jobs to do.
And you don't have to do anything. Just in this year, create a folder of evidence of work. So whether it's Ricardo or somewhere else, you go in your graduate placement, you show your mentor, say, look, this is what I did for a year. Here's my evidence.
Excuse me, Tom. Is it Thomas Bell, the other presenter? Is it Thomas Bell?
Yes.
Yeah, I'll let him in then.
Perfect. Yes, I've recently come off the MPDS scheme. I got chartered in September, so.
Oh, congratulations.
Full of little hints and tips and tricks on how to get them out and do it as quickly as possible with the least amount of sort of manual labour involved.
Yeah, best way for it.
Hi, Thomas. You put your video on, please.
Oh, hello, everyone.
Splendid.
Hello.
Hi, Thomas.
Hi.
Right. Now, so again, are the 2 candidates confident about screen sharing and the usual things with Zoom? You're familiar with it?
I've never used Zoom to screen share, but I'm hoping it's the same as Teams.
If you put your cursor on the screen, down the bottom, there's a green box that says screen share or share screen. I didn't read it. And what I'll do is mute all the participants and then unmute Tom and yourselves. That's unmute Tom Scott and then unmute Thomas Bell and James Morrison. So
Are you going to introduce...
Preaching to a quiet audience, thank goodness.
Who's doing the introductions? Is that
Tom?
Tom?
I'll introduce the meeting and then hand it over to Tom, if that's all right with Tom.
Perfect. And not to spring any surprises, James, I've got you down as first and Thomas down as second. Purely based on the order in which I got your title of your presentation, and that's the order. And there's
no worries.
In it.
Right, we haven't got a vast amount in the waiting room, I'm afraid. In fact, I'm rather surprised.
It's not quite 6 yet, is it?
No, another minute. I can't complain. I joined a meeting a quarter of an hour after it started last night because I think I mentioned to you, Martin, earlier, I was trying to get my iPad to work on a new Wi-Fi, but I made it in the end.
I recently missed one altogether and blamed it on the Wi-Fi. I said, oh yes, I was having Wi-Fi issues, and I just completely forgot.
Yeah, I was going to watch something on Friday night and I forgot. But at least it's more of a concern if you're a host and you forget.
Yeah.
Well, I'll admit the 6 more who are in the waiting room, which includes one of our committee.
Rachel has offered her apologies tonight.
Oh, right. Okay, we're nearly there. Evening, Steve.
Hello, I'm here.
Well, we haven't got many on at the moment. I'll just give it another 5 minutes if that's all right with everybody.
Yep, that's fine with me.
Let me see if we can remember how to operate a Zoom meet. Is there something good on the TV tonight? Is that why nobody's coming along?
I don't know. They're about TV, but Derby County played football last night, so we're not clashing with Derby County.
Did they? It's all a bit academic, isn't it? Now they're all. This guy from Newcastle is supposed to be buying, isn't he? He's another crook, I think. Is that it? Yeah.
I'm not sure you're allowed to say things like that, Dave. It looks like this.
Well, it just amazes me that this club can go down the pan, and all the supporters, 100,000 supporters or whatever, are going to suffer for the actions of a few anonymous people. I can't believe it. I'm glad I watched them when they were doing things and winning everything in sight. And Mr. Clough was in charge.
Mr. Clough Senior.
Mr. Clough Senior, yeah, well, before he got the sack. They offered his resignation, didn't he? And Sam Longson accepted it, a fool. Well, I won't say the queuing up. Sarah, right. Yeah, I'll just give it another 2 minutes till 5 past, and then we don't want to be all night, do we?
Nice round number 5. It'll feel strange starting on 3.
Yeah.
Yeah, Dave, I had a slight problem getting in. I used the link on the poster in the end. That worked fine. But the reminder one that you sent out, it says meeting on the 9th of March on my thing. So I went down and kept clicking until I got one that worked. So maybe there's people trying to get in.
Well, I didn't send a reminder out.
Oh.
I did exactly the same thing.
Yeah.
I got in on the original email.
Yeah, the original one's fine. The poster and everything. It was the more recent reminders I couldn't get in on.
I just get in because I'm the host, so I just go to Zoom.
Yeah.
No, there was a reminder sent out, I think, with the 9th of March, which is I think I picked up.
Right. Anyway.
It wasn't me, honest.
We're here.
Someone joined that 9th of March Zoom meeting.
Yeah.
Anyway,
was in there.
I think we'll start. Oh no, we're not right. Not the round number yet, Tom.
Yeah, so is it worth just sending someone into the 9th of March meeting and seeing if there's anyone scratching their heads?
I don't think you can get into the 9th of March.
No, you can't get into it yet.
I think if people just try like we did and go back to the poster and get it to work, is the only hope. But
I didn't send a reminder out because I wasn't here.
Oh.
I usually send a reminder the day before.
Yeah.
So I only sent out the first one last Wednesday, maybe Thursday. So I don't know where the others come from.
Yeah. The poster one works fine. It's the others. Anyway,
okay.
We're here.
Good evening, everybody. Welcome to the IMechE Future of Rail competition, or presentation competition, should I say. I'm the chairman for my sins. But we have a ex-young members volunteer to look after the competition this year, Tom Scott. We have 2 competitors, or candidates, shall we say, and I'll hand over to Tom and he can explain the proceedings. So if everybody could mute themselves, please. I won't be pedantic and mute everybody myself. And then the guys who need to talk will be able to unmute themselves. So without further ado, I'll hand over to Tom Scott.
Thanks, Dave. As Dave mentioned, I'm the recent Young Members representative for the Midlands Centre, joined in January. So a few short months to put this all together. So we have James Morrison from Ricardo and Thomas Bell from DB-ESG presenting this evening. Really interesting presentations. I was a candidate last year and won my heat, so I think I've got good authority to hold the reins for this event. Could I ask that you turn your cameras off as well if you're not presenting, just to preserve bandwidth, as is commonplace nowadays for those with weak connections, and just to note that this meeting is being recorded, so any comments about the criminal status of various football club owners will be on record. First up we have James from Ricardo, who's going to present on how can we mitigate against ice on overhead line equipment, a study on the effects of icing and potential solutions. So James, when you're ready, if you want to share your screen.
Brilliant, thank you, Tom. Yeah.
And James, you've just muted yourself.
Cheers, thank you. It's come up with a notification to say that the host has disabled screen share.
Dave, you're the host. Are you able to take a look at that? And in the meantime, James, have you got it?
Yep, it's given me possibility now. Okay, please can you let me know when I am sharing my screen?
Yep, it's up now for us all.
Awesome. So as Tom mentioned, this presentation is going to be sort of outlining mitigations against ice on overhead line equipment. As a brief introduction, I'm James Morrison. I'm working for Ricardo Rail, our business unit in the rail sector. And I'm currently on a year in industry from the University of Nottingham, so it's sort of all very local to me. Working and based in Derby, so that's a little bit about me. I go back in September to continue my last year of study So sort of this year has been really insightful into sort of the inner workings of the rail network. So let's hope this clicks through. There we go. A brief introduction on the presentation. This is currently an ongoing project. We're working with RSSB, which I'll outline a little bit later. So the primary focus is a small section that we started with in the beginning. This has been presented to the client and the steering group and has been approved, which is why we wanted to focus on this, rather than doing anything that's sort of still to be refined. There are three main sections: the project introduction and sort of my individual involvement, the key findings from the literature review, and finally some personal challenges and takeaways, so what I've learned from doing this project. So as mentioned earlier, we're working with RSSB. I'm sure all of you are aware of it. For those who aren't, it's the Rail Safety and Standards Board, and cross-industry stakeholders to look at the potential mitigations for anti-icing and de-icing of overhead line equipment. It's project T1219. For those who are interested, the link is down here. Those of you who have used the RSSB catalog can just type in the code. So really what we aim to do is we aim to sort of understand the ice secretion process, its consequences, and potentially any solutions that are present. We're quite aware that sort of a lot of people have a lot of different experience with ice. It's not a new problem. It's not suddenly appeared in the last 5 years. And so what we really want to do is we want to collate all the information that's been presented and that people have into one sort of single source. The findings of this project will go on to inform GB infrastructure and sort of be used for winterization plans for operational managers. Okay, next slide is the project overview. So as I mentioned, this project has multiple stages, and we're just looking at the literature review section in this talk. But I wanted to give a bit of scope on sort of the overall project, just as a bit of background. So the primary stage was the literature review, which sort of provides the foundation for the whole project. Really, we can't do anything else without sort of getting a ground view of what's going on in the world. From this, we're building on some environmental modelling, which is currently ongoing, and mechanical modelling, which is waiting in the wings ready to set off. Electrical modelling is also a part of this aspect of this project, and environmental testing and on-track testing, hopefully, in brackets, will be going ahead. In fact, the environmental testing has been conducted, and we're in the current stages of drafting a report for that. So what I want to go through next is sort of my role and processes for developing the literature review. So sort of the literature review was kind of the first project that really I got stuck into back in September. We kicked off, I think it was the 21st of September. And so it kind of threw me in at the deep end, really. And so sort of I had to kind of figure out where to go. So what we did is we looked at various sources of information, sort of as you can see here in this sort of graphic on the right, academic papers, journals, sort of safety related incident data. We looked at some rail accident investigation branch reports, some really good interesting stuff to get stuck into. Sort of the main focus of this review, sort of because we wanted to get the mitigations accelerated to testing, we really wanted to highlight and pick out these mitigation solutions. The second priority was obviously identifying any relevant practices and experiences from the rail operators. And then finally, we wanted to identify relevant input data for the modelling stages that I mentioned in the previous slide. So once I went through all of these sort of information sources, we dumped them in a matrix, as most engineers do, and commented next to relevant sort of questions that we wanted to answer. So we had sort of 5 or 6 key areas of interest that we really wanted to look into. And then finally, the report was written and presented to the client and the steering group, and feedback was received, and we sort of did a bit of an iterative cycle into sort of making sure that the client was happy and the steering group was happy. Okay, so moving on to the next stage, these are really the sort of the findings of the literature review and probably where most people are interested. I know I certainly am. So ice is a bit of a tricky subject. Sort of there are different ways of categorizing ice and different factors for why ice occurs. I'm sure most of you are familiar with sort of ice on car windscreens as sort of your main encounter with ice or slipping on black ice. So sort of various methods for categorizing ice are sort of how accretion occurs, which is just how it develops, how it propagates, and also based on sort of appearances. So sort of precipitation icing is typical for sort of ice formed in freezing rain or snowflakes. So sort of a particularly stormy weather would sort of leave precipitation icing on the contact wire. And just sort of as a bit of a overview, sort of glaze icing, sort of mentioned here in the appearance, it's typically sort of transparent with density between 0.6 and 0.9 grams per cubic centimeter. And glaze sort of covers wires with strong adhesive bond, which is sort of difficult to remove. So key factors for ice secretion, sort of your obvious temperature. It's not gonna form in sort of plus 25 degrees C. What we found is ice typically forms between 0 and minus 10 degrees C. Sort of the lower you go, the harder ice is to form. Liquid water content is another key factor. Sort of the lower the diameter of the droplets sort of affects how the ice itself forms and can again sort of affect the categorization of ice. Time is an important factor. Obviously, ice doesn't occur instantly. And interestingly, wind speed and direction is a factor of note. We find that sort of if the wind is perpendicular to the contact wires, it sort of ice forms faster because sort of the wind is the delivery of the water in the air or the water vapor even. So sort of if you have the wind running parallel to the wires, there's less chance for the water droplets to impart on the overhead contact wire. And finally, of note, sort of the client is keen to emphasize that sort of locations near tunnels and bridges where you've got potential for drippage is sort of a key factor as well. Sort of you'll get more icicles rather than a sort of a cylindrical sort of load. Okay, I'm just sort of keeping an eye on time and hoping I don't go over. Okay, so the consequences of ice is the next area that I looked at. Sort of various consequences. Of note, sort of abrasion, ice is typically quite rough, although slippery. It can form in irregular patterns and can sort of lead to increased wear on the carbon strip. I'm going to just play this video as a bit of a point on the next section, if it loads. So electrical arcing, I'm sure most people are aware, is not ideal. I'm really hoping this video works, but if not, no worries. So if you, as you saw from that clip, you can really see the impacts of the ice on the overhead contact wire. It's causing an arc to leap from the overhead line equipment. But of note, it's not leaping from the wire to the carbon strip. It's leaping from the overhead line to the aluminium carrier. And this is causing particular damage because it's sort of up to 3,000 degrees Celsius. Which is obviously melting the aluminium, sort of melting the glue, and causing all sorts of nasty problems. Other issues with ice on the wire, sort of increased weight and tension on the wires, changes in aerodynamic behavior and sort of kinematic sort of behavior, as emphasized by the galloping of the contact wire, sort of oscillations in the wire that shouldn't really be there. And all of these can sort of help contribute to potential dewirements, which are preferably to be avoided if we want a sort of a successful rail network. Okay. So the next stage was sort of looking at theoretical models. I found this a little bit less interesting because it was very sort of academic. So there are various papers, sort of different modeling techniques. IMechE, Goodwin, and Morrison are sort of the three primary models for ice secretion. These are primarily from sort of power networks, power supply grids, because icing isn't just a railway problem; it's a problem worldwide and across sectors. So I think Morrison is sort of working in Canada, or has been working in Canada, on their power grid there. Dynamic models for sort of the pantograph contact wire sort of interaction have also been found. Sort of there are different ways of modeling methods of ice, and I think sort of there's also sort of Chinese paper with dynamic analysis of sort of pantograph catenary system, considering different ice coatings. Electrical modeling is notably more difficult because sort of electrical properties tend to change with the time. So sort of when an arc is created, drastically different conditions from sort of when it propagates, even down to the millisecond of when it's leaping. But we did find some electrical properties, and there are some models that can predict sort of critical flashover. Okay. I'm just conscious of time. So infrastructure mitigations, these are the ones that we were really interested in, because sort of what we want to do is we want to be able to tell the client and the stakeholders, look, this is what we suggest would be suitable for the GB rail network. So we've looked into them, and there are sort of some that are better than others. Some of the ones that we found are sort of thermal or resistive heating of wires, which the basic operating principle is it melts the ice on the contact wire. It's not too complicated. Other ideas are anti-icing and de-icing chemical products, sort of glycol-based, that gets either sprayed or is sort of applied with a felt roller. Other potential mitigations for infrastructure include sort of manual de-icing, but there's issues with this behind sort of isolation. You don't want to be touching live electrical cabling if possible, although there is a scary video of, I think it's a Chinese process of de-icing, and it's just sort of workers banging sticks against the wire. This is typically done as sort of a last resort kind of thing. Up in Scotland, we're aware of sort of ghost trains that run in sort of particularly wintry conditions. Basically, the principle behind this is to sort of keep trains moving to sort of clear off ice as it develops, and so it's really not given that length of time to develop into something nasty. Okay. There are certain sort of things that you can do with a pantograph to try and help mitigate it, the damage done by ice. So sort of one of the primary things that are in use at the moment is auto drop detection systems. So sort of when a crack is detected, in fact, I've got a sample here. I don't know if people can see on my screen. There's a small sort of hole inside the contact strip, and when sort of a crack is formed, this is pressurized, this hole. And when sort of the pressure drop is noted, the pantograph drops. However, the issue with this is it's sort of it's almost too late to solve the issue. It stops any further damage, but it doesn't really solve the problem entirely. Icebreaker pantographs are sort of available. On the diagram on the right, you can see sort of a copper leading edge that works to scrape off the ice, and then sort of the carbon strip behind. Arc protected pantographs are also sort of looked into, which is basically where you wrap it in silicon to prevent the arcing that was sort of seen in the previous video. So this really insulates the pantograph to try and stop any damage from the arcing. Okay, so that goes over the results from the literature review. The next steps, I sort of touched on it a little bit earlier, but we've finished the literature review. The project steering group is going to be meeting soon to help to discuss sort of the environmental modelling and the progress that's been made, and really that's sort of going to enable the mechanical modelling to occur, because really we want the results from the environmental modelling to be used as inputs for the mechanical modelling. As I mentioned as well, the environmental chamber testing has been completed. What we've done is we've sort of taken what we've learned from the literature review, and we've tested some anti-icing products, but I can't go into too much detail because that's not being reviewed by the client. We are in the process of drafting said report. Okay, and then sort of closing up the presentation, some of the personal challenges that I've found with this project, with me being a year in industry student, I'm only an intern and therefore have very little experience with the rail network. So sort of this was kind of trial by fire, or trial by ice even, I should say. So other challenges include sort of looking to impress new colleagues. The sort of new kid to the block has sort of taken this on and sort of tried to use it so that people can talk between the colleagues to say, oh, James is sort of works hard, that kind of thing. But they're sort of more personal challenges. More technical focus is sort of the difficulties that I've found is sifting through relevant information and evaluating the quality of sources, which has been interesting. There's lots of information out there on the internet, and really the challenge has been sort of finding what's useful. In particular, finding what's necessary, but that is hard to find that meets the client's expectation. Now, the client is particularly interested in sort of areas around tunnels, and they've had anecdotal evidence of sort of issues coming from tunnels and bridges. However, this is a niche subject in even sort of in an already niche area. So sort of finding information both on tunnels and overhead line equipment has been a challenge. And finally, sort of knowing when to stop looking for sources. I'm quite a curious person by nature. I think that's probably why I've done engineering as a degree. But really, it's when do I stop, and question whether or not my curiosity is taking the better of me and I'm not really adding any more value to the literature review. But these challenges have helped form personal development. So what I've learned has based more around track infrastructure and pantograph design and maintenance, sort of getting an insight into some of the issues that have occurred, not just with ICE, but in general. I've also increased confidence in myself while presenting to colleagues, clients, and stakeholders. And in fact, this presentation is helping improve my confidence because all the experience is useful. So understanding the process of producing a literature review has been really useful because I imagine this won't be the last work I do in new topics, and having a basis in sort of research is always going to be useful. And finally, sort of more on the testing side that I haven't touched on, but I've got practical experience now for developing and conducting testing that's going to be used in industry. So that really ties up my presentation. I hope I've not overrun. Thank you for listening, and I'd like to thank the client RSSB for their support on this project. If you are interested in this project, I would encourage you to head over to the RSSB catalog and register your interest with this project. Again, that code is T1219. I've been James Morrison, and thank you for listening. Does anyone have any questions?
Brilliant, James. Thank you for that. I was noting down questions as you were going along, but you seem to answer them on the next slide.
Oh, brilliant, brilliant.
If anyone does have any questions, we haven't got a raise hand feature, so if you pop a question mark in the chat so I can sift through names of people who have questions, or shout out, whichever you prefer. I'll make a start. You talked about icing causing damage to the pantograph.
Yep.
Do you see much damage to the wire through icing? Other than you mentioned it adds stress and strain, but when the train's going along scraping the ice, do you see reduced life or damage to the wire?
No, that's a great question actually. As you mentioned, sort of the damage is particularly on the carbon strip. However, sort of in instances of dewirement, it can hook underneath the horns of the pantograph, which can in fact, I think I've seen a pretty scary video of the whole overhead line equipment coming undone from sort of icing causing galloping. So yeah, overhead line equipment damage is prevalent, not prevalent, even present, but sort of certainly the focus is on sort of protecting the carbon strips. But yeah, great question. Hope I've answered you. I hope I've answered it sufficiently.
Thank you. I see we've got one from Martin that's popped up in the chat. Martin.
Yeah. Thanks, James. Great presentation, by the way. Just a question really about the environmental testing that you say you've completed. Clearly, I'm guessing it can't have been sort of full scale, a pantograph on an overhead wire. So, what exactly did you test and how did you go about that?
So, great question, Martin, and thanks for asking it. I would say, as a point of call, is probably to wait until the draft report has been sort of approved by the client. I don't want to sort of be going into too much detail, but what we've tested is sort of anti-icing products on sort of 1 meter contact wire strips. We also did a little bit of testing on the catenary wires or catenary. But sort of it was in temperatures sort of 0 to -10 in an environmental chamber down in Shoreham. But unfortunately, that is as much detail as I can probably give you without wanting to sort of jump the gun almost on that research. But the report will be released, and hopefully I will have that for if I get through to the next round.
Okay, thank you.
Sorry, Martin. I'm afraid I couldn't answer that question.
No, that's fine. Thank you.
Perfect. Yeah, so it's the nature of sort of projects like this, James. You understand there's certain things you can and can't say when dealing with external clients. I've had similar issues before. I've got one from Thomas.
Oh, sorry, I was just going to say it was really exciting, the environmental testing. So I'm looking forward to being able to present that stuff. Sorry, go on, Tom.
Yeah, I've got one from Thomas Bell if you want to unmute yourself, Tom.
Yeah, of course. Thank you, James, for that. That's actually a very, very interesting topic to me because I've done a fair bit of pantograph testing out in the field. I think on one occasion I was stuck somewhere outside of Amsterdam for a couple of hours because of excessive arc to the ice. So certainly if you could find a way to get rid of that, would be making my life easier. One thing I saw in countries, typically countries that have DC OLE systems, I'm thinking of the Netherlands and Belgium here, it's quite common for them, rather than sort of running a ghost train like you mentioned, they'll just run the first train of the day in what they call de-icing modes with multiple pantographs raised. The first one drawing currents to prevent any arcing but to clear the ice off, and then the second pantograph, the trailing pan, draws the current on a now newly de-iced OLE. I was just curious as to whether it's something you've been looking into as part of your research. I didn't see it mentioned in your list.
Yeah, so that's a great comment. We have been looking at sort of worldwide solutions. We've been in discussion with infrastructure operators in France, and you're quite right. There are sort of different countries have different way of dealing with ice. So I think if I click back, I don't know if this is going to work actually. If I click back to the infrastructure, so sort of I glossed over it a little bit in sort of aiming to keep on time, but yeah, scraper trains are a potential solution to the issue, sort of almost a sacrificial lamb to run over the contact wire. The issue is sort of usually the first few trains of the day you want to be getting out as quickly as possible, and sort of if the scraper train goes down, you're sort of blocking up rush hour traffic. But it is definitely a solution that could be looked at, and we would encourage sort of the train operating companies to look into that as a possibility. So you're quite right, Tom.
I'm terribly sorry, James. I might have not expressed myself properly. So what I meant is having a single train with two.
Sorry, Tom. I think you've broken up for me. I don't know if anyone else has experienced that. Whether I've broken up with Tom.
Can you hear me at all?
Yep. You
can. Okay. Yep. I'm sorry about that. You might have not fully understood my original question because of clearly the internet issues I'm having. So I was asking about not separate scraper trains, which have operational disadvantages. I was asking about having a single train with two pans raised. And so you have the first pan to mechanically remove the ice, not drawing currents. And then the second on the same normal passenger service train draws a current. Is that something that you've seen done at all in the UK?
I'm trying to recall if I've seen anything. Nothing's jumping to mind, but that's definitely something to look into. I know sort of in the sort of the first few trains London to Edinburgh, there's kind of sort of anecdotal evidence from one of our colleagues where basically the sort of you have to change pantograph head halfway up the sort of the line in the first train to sort of adjust for that. So I think that is a potential avenue to look around. So thank you, Tom. We'll sort of bear that in mind.
We'll just take two more, conscious of time. We've got one from Anthony Cash. I'll read it out for you as it's typed in the chat. An elementary question for you. How would you describe the difference between anti-icing and de-icing?
Yeah, great question. Sorry, I probably should have clarified that. So anti-icing is a preventative measure, whereas de-icing is a sort of a remedy. So anti-icing is typically done before the icing occurs, whereas de-icing is sort of a spray when you've got ice actually on the contact wire. Yeah, great question, and thank you for allowing me to clear that up.
Perfect. I think that answers that perfectly there. And we have the last one from Liam Purcell. James mentioned 3 types of modelling work. What is the relevance of these 3 different disciplines to this project?
Sorry, could you repeat the question? I think my internet was breaking up a little bit. At the
bottom, it's written down. Or Liam, do you want to unmute yourself in?
I think I've unmuted myself.
Yep.
You mentioned 3 different types of modelling work.
Yep.
mechanical, and environmental. What is the relevance of these three different disciplines to this project?
Yeah, so great question, Liam. Environmental modelling is really sort of to get a basis and an understanding of how ice develops on the contact wire. What we've seen in a lot of our literature is that sort of icing has really been studied on power lines, whereas the contact wire has a bit of a unique geometry, and sort of it's typically different to the sort of the literature that we've seen. So we wanted to get a firm understanding of how it develops, particularly on the contact wire. This environmental model is then used to sort of fuel the mechanical model. And so the mechanical model is really to sort of understand how the quality of the current collection is affected by sort of ice on the overhead line equipment, sort of with your standard, not standard metrics, but sort of with outputs being sort of percentage, sort of contact time, and sort of average contact force. The electrical modelling is sort of to analyse how sort of the electric current runs through the ice layer, to see sort of the impact on that. Does that answer your question, Liam?
Yes, thank you, James.
Brilliant, thanks.
Oh, perfect. Thanks for those, James. Yeah, really interesting presentation. And I'll definitely be looking at the report online for more information, because that's something that I've never considered. Ice on the overhead line. I've always considered sort of snow and ice on the tracks, but never above my head.
No, it's quite interesting actually, because sort of I live by Nottingham trams, and so sort of in the winter you do hear the sparks of arcing, sort of even on the tram network. But yeah, quite right, Tom.
Next up, we have Thomas Bell, who's going to present on introducing 3D printing to rail operators.
Thank you, Tom. Bear with me 1 second while I share my screen.
I think I've... There we go. Yep, that's come up.
Excellent. Right. Well, hello, everyone. As Tom said, I'm Thomas Bell. I'm a mechanical engineer with ESG. Been there since coming out of university, which was in the summer of 2018, so getting close to 4 years now. Here to tell you about bringing 3D printing to rail operators across the UK. I thought I'd give you a bit more of a personal perspective on what it was like for me coming out of university, what challenges I faced, what I managed to get done, rather than sort of giving you the sales pitch, which I'm sure a fair few of you will have already heard countless times if you're professional engineers. So my background, like I mentioned, went into ESG straight out of university. I was a Master's of Mechanical Engineering at Sheffield University. I did a lot around new technologies. I looked into condition monitoring. I did a lot around additive manufacturing, 3D printing. Top picture there is my thesis, which was inkjet printing a transistor. Below that, you've got something which I was studying in my lectures, which is laser melting raw elements to form eutectic alloys, which then gives you various advantages when it comes to latent thermal stresses. So ESG hired me because of that kind of background, because they wanted someone for their new technologies team who'd be able to bring that kind of thinking to the company. I've now moved on to a more generous role, as most people often do, get involved with larger projects. But 3D printing is really where I cut my teeth as a professional engineer. The reason ESG hired me, in 2018, this is kind of where ESG stood with 3D printing. A large 3D printer manufacturer, people called Stratasys, who were pushing hard to get into the railways, presumably trying to sell people printers, not realizing that the UK railways are very fragmented and very few companies can afford to spend 6 figures on a 3D printer. But nonetheless, they caught my manager's attention, mostly because they'd already secured fire compliance ratings for their plastics. And when I joined, the picture on the right is the kind of stuff we were doing. So this is something that Stratasys made for us. We gave them the 3D model for an armrest, I think out of the class 15X. They printed it and gave it this fancy looking, sort of slightly funky surface finish. Unfortunately, once we cut that part apart to investigate it, we found that they'd sort of given it a very hollow filling on the inside, which meant that it didn't comply with structural standards in any way. So you had strategists who lacked the rail industry knowledge. You had ESG and my boss Martin, who very keyed into the railways and really could see the opportunities that 3D printing could bring us as a consultancy, but didn't have that fundamental academic knowledge of 3D printing, and that's why I was brought in. So very quickly, why a rail consultancy would be interested in 3D printing. The top image is the kind of stuff you see in sort of press releases, at least those intended for the layman, around 3D printing. You often see highly optimized complex geometries, titanium alloys, the kind of stuff that's used in, say, the aero industry, where you actually are willing to spend a lot of money to shave a few grams off a part to optimize it, etc. Frankly, it's not of much interest in the rail industry, which is much more conservative. Where we saw the real value in 3D printing was in the kind of the digital manufacturing process. The idea was, say you have an obsolete part which you can't get mass-produced, stocked anymore. Well, it's actually quite easy to reverse engineer it. And once you have a 3D model to produce it using 3D printing technologies, you don't have to worry about the time you spend on drawings. You don't have to worry about tooling costs and other setup costs by manufacturing it in conventional means. You just 3D print it as needed, and you don't need to hold stocks of some mass-produced parts. And before I go into the exact work I did around 3D printing, I'll just give you a tiny bit of background, but I'm conscious of the time limits. Very quickly, basics of 3D printing. To the left, you've got the FDM process, which is probably the best understood. And it has a lot of advantages, but good service finish is not one of them. That's basically just depositing a molten plastic filament onto a build pattern, layer by layer, and those layers slowly build up to give you a complete part. In the center, you've got laser sintering, which is starting with very, very fine, loose plastic or metal powder and melting it into place using lasers. Again, layer by layer. Advantages, you get much better service finish. Disadvantages is typically costs and a more limited material choice. Then on the right, you've got either DLP or SLA printing, depending on who you ask. But this is UV curing a resin using laser beams. That gives you excellent finish, but the main issue you have with that is, given that you're relying on a UV curing process, you're very, very limited when it comes to materials. This one on the right is basically unused outside of prototyping, at least in any kind of serious industrial application. So joining ESG, obviously 3D printing was still at the R&D stage for us. So this is what I was focused on for perhaps the first year or so. The first order of business was, as soon as I was informed that one of the parts we were looking at was armrests, grab handles, and so on, all parts which are subject to structural standards, my biggest concern was immediately fatigue life. Like I said, FDM printing, which is what Stratasys was selling, is built layer by layer. That results in a highly anisotropic material, to use the correct term, meaning that it's much stronger in one direction along the layers than it is in the other direction across the layers, especially in fatigue rather than just ultimate strength. That was a big issue. We ultimately resolved that simply by accepting that we'd take the conservative approach and saying all our FEA analysis will be done assuming the worst case strength in all directions. We looked at specialist software. We eventually made the call that it simply wasn't worth the expense and the extra bother during the FEA stage. Fire compliance is a big topic. Like I say, Stratasys and their material, they'd already certified it. We knew that was compliant to requirement set 1, if anyone in the audience is familiar with EN 45545. But there was also a focus on finding other materials that were perhaps cheaper, perhaps gave you a better finish, like using laser sintering, which also met some kind of a requirement set, say requirement set 22 or 24. I also looked at design optimization, which is the picture on the top right. So this is topology optimization software to try and create the sort of fancy bracketry that they use in the aero industry. It was a very interesting month looking into that, but obviously we decided not to go with it in real applications. We just didn't see enough value to justify purchasing the software. Bottom right picture is some impact testing we did. So this was an FDM part, which we coated with a polyurea polyurethane blend as a coating. The idea was not only to clean up the finish, but also to give it extra impact strength. This part is a prototype axle box cover, which we took to a rail windscreen testing rig, where it had small projectiles thrown at it at up to 125 miles an hour to see how it held up. And as you can see from the picture, it did fairly well. So we managed to get, out of a material that is fairly brittle originally, that doesn't have much elongation of break, we managed to get a decent bit of toughness out of it. The most important part of R&D really was getting the coatings right. Bear in mind, especially when you look at plastic 3D printing, small interior furnishings are a very big topic. With small interior furnishings, you have to worry about aesthetics, about PRM compliance. The finishing has to be right. And with the way Ultem comes out of the printer, it's a very rough surface finish, but Ultem is also a very tough material, which makes it hard to sand down. In fact, you can see on the very left, this picture is a part that was over-sanded. A supplier who was sanding down a part before painting it got slightly overzealous and affected the part's shape, rendering it unusable. If you try to take a slightly softer approach and say, use a bit of filler but not sand the part down, you ended up with what we have in the middle, which is a failed crosshatch test. The paint just didn't adhere properly to the substrate. On the far right, you can see an example of what that looks like with respect to finish as well. Some parts of that armrest are quite smooth, others are visibly rough, and the paint just isn't sticking properly. We eventually had to essentially come to a compromise and just accept that there'd be a lot of expense in sanding down parts where we needed to use Ultem, this highly fire-compliant material. In other cases where we can get away with less, the focus has been since then to simply use different processes, different materials that give you a better surface finish. Eventually, all the R&D culminated in this article, which I was quite happy made it to mainstream media, Sky News. So we had the first replacement parts to go into service on the UK network that were 3D printed, which I'll show you now. So here you have some grab handles used by Chiltern Railways. This is a part that was originally in aluminium casting. The casting master was probably carved by hand back in the late 80s. Definitely weren't any drawings of it. Definitely weren't any CAD models of it. And it simply wasn't available anymore. This is a part that's critical to PRM, that's very much customer facing, and they were starting to break. Chiltern needed new ones. If they couldn't source that exact design as a replacement, then they'd have had to retrofit an entire train set with a new model of grab handle with a different design, which would have cost them a lot of money. So it was the right opportunity for us. So we started off with an Ultem part, which you can see in the bottom middle. We designed it up, got it sanded and painted, went to fit it on the seats. First issue we encountered was we had some small metal inserts that slotted into the main plastic body, which you could then screw into. You don't want to be screwing straight into 3D printed plastic. Those inserts were originally designed to be circular in cross-section to prevent stress concentrations in the plastic body of the grab handle. That made them very hard to fit properly in the right direction because all the surfaces are slightly angled and it has to all come together just right. So we designed the inserts again and obviously had to redesign and reprint the handle as well. Only to find that clearly the handles had been sort of, let's say, installed in a coach-built kind of way onto the seats, and no two seat backs were exactly alike. The holes were drilled in slightly different places, which meant that with our nice, consistent 3D printed design, some handles stood proud of the seat back by 5 millimeters, others didn't fit. So we had to go back to the drawing boards yet again, and we came up eventually with a kind of a design that had some flex built into it, using captive bolts and captive nuts that allowed the handle to sort of wiggle onto the seat and fit just right before it was tightened down. you can see how we use 3D printing for prototypes and jigs to help us get the design just right. Another big challenge on this was, like I mentioned, the part was clearly sort of hand carved. We certainly couldn't find a drawing of it. When we 3D scanned it and attempted to have our designer reverse engineer it and make a CAD model, we ran into some pretty major issues. It was almost impossible to design the part using conventional parametric CAD. We had to end up spending days getting a surface model made, which was a highly stressful thing for a project I was leading with, at the time, less than a year's experience as a professional engineer. But we got there in the end. And like I said, we got the nice headline in Sky News. Since then, since 2019, which was the introduction of this part, we've made probably less than 100, but certainly several dozen 3D printed parts for a bunch of rail operators. We've collaborated with Angel Trains on this, who've been very keen on this technology since the early days. You can see a few examples here. So I've got cowling from the cab of a Class 165. I've got a CNC manufactured part for a Bombardier overhaul, Bombardier now Alstom. We expanded into CNC as well because we realized we could use the same digital manufacturing process with CNC machining just the same. We could still work on a purely digital basis. We could still do 3D scanning. We could still give our suppliers digital files, not have to draw them up, but we could also get fairly cheap metal parts using CNC. And bottom right is what we're focusing on nowadays, which is creating a web portal, which will hopefully help rail operators order replacement parts as they need them using 3D printing and CNC in the future. The idea is that we'll take a lot of strain off of stores in various depots across the country. But the thing I'm happiest about really is how 3D printing was integrated into our business as a whole. Shortly after our big success in introducing these parts on Chiltern trains, I was asked to present to the entirety of our engineering and projects teams, just to explain to them what 3D printing was, what it could offer, and why we'd been looking into it as a business, why it was so interesting. And the result of that has been very, very good. I had a number of projects engineers come up to me and thank me. And the perspective has definitely changed. It's now really quite common to be in a meeting with customers discussing something completely unrelated to 3D printing. And then we'll just say, oh, well, we could use, say, a space envelope model for something. Why don't we 3D print it? Client shows interest. We bring out, some example 3D printed part we made a few months ago. And their eyes light up because a lot of people don't realize how much you can get out of 3D printing nowadays. So picture on the top right there is a space envelope, for example, for this was fitting ETCS to a cab desk. It required some equipment to be relocated. There was a doubt. Someone thought, is this piece of equipment going to clash with the cab desk once it's relocated? Didn't know. We made a rapid space envelope using our Office 3D printer. Got it onto the locomotive. Turns out it did clash and we knew how to relocate it. Bottom right, that's a fitment jig. We had to drill a bunch of holes in a relay enclosure. We wanted the holes to be aligned properly, but we also wanted something to catch all the swarf. So we built this little jig that has magnets glued into it to retain all the swarf. Another big victory was convincing our very conservative drawing office design department to put into place a new procedure for us. 3D printed parts, the master is always the CAD model. The drawing is only there really for info, for record keeping, and so you can assign the part a number and catalog it onto pads. And so we convinced our drawing office to have, instead of the classic drawing that shows every critical dimension, a drawing that shows you an overall view of the part, then gives you a table of 3D printing parameters, which is really what's most critical. And those are now in common use. So just to finish, and I do apologize for having gone slightly over time, this is where ESG stands as of the year 2022. These particular pictures are from a few months ago, so it's still 2021. But I was working on a completely unrelated project. I was overseeing modifications to a power controller. Some colleagues who were routing harnesses through a bunch of coaches spotted these little plastic clips which hold fluorescent tubes in place on the ceiling. They had to take these the ceiling trim off in order to route some harnesses. And as they removed the fluorescent fittings, these little clips kept breaking because it's become very brittle over 30 years in service. It's one of those small things that turns out to be a big problem. It was actually, it was something that made me very happy because it's not something that I had to notice myself. My colleagues came to me, said, we're having this issue. The small plastic part is breaking over and over again. Can we 3D print it? Of course we can. I took the part, gave it to a grad who was working in our design office. He reverse engineered it. We had a 3D model. 2 or 3 prototyping runs later, which cost us all £50 each, we had a clip that fits perfectly, which I was able to take on the train while I was on site visits, looking after my main order of business, this modification work, until we got just the right fit, until the fluorescent tubes clipped in place perfectly. After that, all we had to do was get 1,000 parts manufactured, hold them in stock, and now we have a very grateful rail operator who knows they can come to us if they ever need one of those replacement clips, which is a big change from where we were in 2018 when I joined ESG, I think. So I'll end here because I know, again, overtime, apologies for that. I'll just say thank you for listening, and I'll happily take any of your questions.
Perfect. Thank you, Tom. There's a couple of questions in the chat. So Anthony Cash. You there with the mic, Anthony, or do you want me to read it out?
Yes, sorry. So thank you very much, Tom. So I was particularly waiting to watch your presentation, enthralled by it. I love 3D printing. And sadly, the UK expert on fire for EN455 Part 2. So if you don't know the answer, it's absolutely not a problem. But how have you managed to deal with the fire compliance challenges of a particular clause in that standard, functional necessity versus, you know, commercial off-the-shelf products? Because that's a really contentious issue in the fire fraternity. Thank you.
That's an excellent question. It's something we've mostly avoided. We found it easier in most cases to simply either, you know, spring for the ULTEM, which is R1 compliant, so you can use it essentially anywhere, but comes with these drawbacks I mentioned of being very tough to finish and being quite expensive. Either that, or you know, we'll use clever thinking. Say we'll have a design that's mostly metal, but then just incorporates the occasional 3D printed part here and there where it's really critical, where you can't use box standard off-the-shelf components, to reduce the waste, to keep it under, say, the 100-gram threshold for R24 compliance. I have dealt very occasionally with the clause you mentioned, but never in the context of 3D printing. And frankly, given how hard it is to use personal judgment when assessing against 45545, as opposed to the good old days of BS 6853, I think it's probably for the best. It's just easier to get a material that's compliant.
Thank you. That's a very good response to that question, and I'm sure you'll be able to contact me if you want to delve into that deeper.
Oh, certainly. Thank you.
Perfect. Thanks for that, Tom. Any more questions? Oh, we've got a question from Sarah. I noticed on your iPhone, you able to yourself, or do you want me to read it for you? I think I can hear you in the background there, Sarah. No, okay, I'll read it out for you. Sarah's put she is curious about the policy of printing parts and holding them in stock for operators to contact you about if needed. Is that a usual approach to stock?
No, perhaps because I was rushing because I knew I was over time. I could have explained it slightly better. So with the last example of the night clips, when they broke, the operator was aware that they broken, and they sort of brought up in conversation, oh, we know about those things. They keep on breaking on us when we do other maintenance work. It's an annoyance, but don't worry about it. And so the selling point of working for the consultancy that has all the 3D printing experience was being able to tell them, well, actually, we're going to be able to make replacements to make up the ones we break as part of our work, and we can also supply you some more to make up for the ones you break in your normal operations. So the only reason we had 1,000 made is because we knew the operator in question was actually going to take them. Otherwise, generally, like I said, one of the big advantages of 3D printing is you don't need to hold stock. All you need to do is hold the design master. Since, excuse me, since you don't have to worry about tooling costs or setup costs, really, you're best off just printing the amount you need right now and then holding the model for future use when someone comes up to you again and says, well, I need 10 more of those.
Perfect. Thanks, Tom. I'll take one more question from Chris Beals.
Yeah, thanks, Tom. Obviously, we live in a quite environmentally conscious world. In terms of that, how sustainable is 3D printing?
That's a good question. It's also quite hard to quantify. You can certainly do 3D printing with recycled materials. It's something that's been increasing in interest over the past few years for rather obvious reasons. One of the most popular materials for recycling is PA11, nylon 11. Also PETG, which is polyethylene with glycol. You get a lot of that happening in the sort of the hobbyist markets and perhaps in some industries. Sadly, mostly because of the fire standards which were held to in the railways, it's not really something we can do. However, I do think with 3D printing, you have this argument of, you're using additive manufacturing. You're building up the parts using the material you need and not an ounce more. Comparing it to, say, CNC machining, where you're starting off with a big block of plastic and then cutting away half of it, which ends up either wasted or recycled into inferior quality plastic. In that sense, I think it is a fairly sustainable approach.
Thank you.
Perfect. Thanks for that, Tom. Do you want to take your screen off share, if possible? So that's our two presenters this evening, both very informative presentations. Our judges are now going to break and go into a separate meeting room. Probably should have introduced those at the start. We've got Liam Purcell of Ricardo. We have Martin Elliott, Vice Chair of the committee, and Chris Beals, who's Young Rail Professionals representative. They're going to break and judge. Whilst they're doing that, I'm going to welcome Dave Coxon back, who is the chair of the Midlands Centre, and he's going to do the AGM whilst the judges break. And there he is.
There I am. Thank you very much for that, Tom. Thanks to the two presenters. Very interesting. I don't seem to be here. Where am I? Well, you can hear me, I hope. In this break, while the judges are deliberating, we will have a curtailed AGM for the centre. I say curtailed because we can't pass out all the documents we might normally pass out. So we take it as read that the previous minutes were available on the meeting on the 14th of March last year, which was another Zoom meeting. But the chairman's report, and that is my report of what has occurred since I stepped into the breach. We had an interesting year, put it mildly. We had a number of Zoom meetings at the beginning of the year. This is the year 2021, of course. We're going, we sort of overlap between the year and the session between the 2 years, if you follow me. So the beginning of 2021, we were totally Zoom meetings. But after the summer break, we decided we would like to resume face-to-face. But unfortunately, the Derby College, which was our normal venue, as you probably remember, and which was an excellent venue in terms of its facilities and proximity to the railway station, and not to mention the free car park, they decided they would no longer host the events at all. So we were struggling in the summer to try and find an alternative. As those of you who braved the stairs may remember, we went to the Waterfall, which was the original Midland Railway Institute. which in theory should have been the place for something like our organisation. But unfortunately, there were several things that conspired against meetings there. One was the reluctance of people to come immediately to open meetings after they closed down. The second was we couldn't start at the original time because of limited parking in the area, which was not available until after 6 o'clock. So we had to put our start time back till 6:30. And from comments made by people who were working, I don't count myself in that category, 6 o'clock was a little bit too late. I mean, if it's 5:15 as it used to be with a few sandwiches, we could you could stay in the office an extra half an hour. But 6 o'clock for 6:30 was getting a bit late, and a late finish, of course. But we did manage to have 3 meetings there. We had a very interesting talk about overhead line testing on the Midland. We had the chairman's address, which was very lively. The new chairman, James Collinson, is an excellent all-round railway engineer. And not only is he worked for Network Rail, but he even knows what traction and roller stock is. So to my view, he's an excellent chairman. We then had a meeting about the Coventry Very Light Rail, which is another innovative system where the rails are perhaps a bit like train sets, pre-assembled and laid down on the road or in the road, but with minimum disturbance of underground services. So if they needed to be accessed, it would be fairly straightforward to do that. Very innovative and going places, I think. So we had an average attendance of the Zoom and live meetings of 45, which again is less than we would normally expect for a full season of live meetings, but it's pretty good, really. It's 45 is about 3/4 what we might normally expect. So we were pleased with that. We've also continued to hold joint meetings with Derby Railway Engineering Society and the Peeway Institute. The Coventry meeting was the Peeway Institute, and DRES asked me if I would like to tell everybody about taking trains into Europe before the tunnel. And that was a Zoom meeting hosted by DRES. And I think it went down quite well, quite interesting, I think, for most people who don't see the sea very often. But as I said earlier, the big blow was in the summer was the fact that Derby College wouldn't let us go there. And for reasons I explained, the waterfall is not suitable. So at the moment, we've resorted to Zoom meetings. We will continue the next 2 until April and Zoom. We have a planned visit to the Great Central Railway, which is stalled at the moment, but we are hopeful we'll get to moving on that. We have an itinerary. We just need to run it by GCR again and cross the T's and dot the I's. The finance situation, we have a healthy bank balance, mainly because we've hardly spent any money. But we did talk last year about the PA equipment being a bit life expired, and we found the first meeting this year, we needed a projector that would talk to various laptops, and ours was perhaps a bit life expired. So we bought a new projector. Which ironically, this equipment has not been used to its fullest extent yet because we've been doing Zoom meetings. But we are ready and waiting and willing to go. And at the moment, we are actively searching for a location where a venue where we can do live meetings. And I think we have one on Pride Park, but I won't say any more because I haven't got confirmation yet. The election of officers. The nominations were received last year. That was myself, chairman. Martin Elliott is now the vice chairman and secretary. Christian Cormanios is the treasurer. Dr. Joanna Lewis, published as secretary. And Tom Scott has been seconded from the young members to be their representative on our committee. The remainder of the committee are valuable members who contribute to the overall workings of the centre, and they are Bridget Eickhoff, Richard East, Steve Dentith, Paul Long, Nick Sarosi and Peter Stanton. All of these have been re-elected in 2019 to serve 3 years. So next year they'll all be looking to either resign or offer their services again. We need to establish Tom on the committee. If people would like to, or somebody would like to second Tom and have a seconder, they'll unmute themselves and allow us to accept that, and then we can officially get him onto the committee. But further to that, if anybody else would like to join our illustrious band of brothers and sisters, then please let it be known and send emails to myself or any member of the committee. You don't have to stand up and be counted today. So that is really the sum of it all. If anybody is willing to to propose Tom as a committee member, I don't think I can do it myself.
I'll propose him.
Thank you, Liz. Any seconder, please?
I want somebody.
You're not held. It doesn't cost anything.
Could Jason do it? Because he was the one who put me forward.
I've managed to, Steve Dentith here. I've managed to unmute myself, so I will do that.
Yeah, Jason's available, Tom. But thank you, Steve. So it formally recorded that Tom is now a member of the committee representing the young members' interests. And thank you, Tom. So without further ado, that is the end of the official business. If anybody's got any questions, I'll be happy to answer them if I can. In the meantime, we will wait for the judges to come back to us. As long as I'm not missing anything in terms of people in the waiting room. Where are we?
I'm just sending the judges a message now, Tom, to come back across.
Right, thank you. I don't know why I'm not on the screen, but never mind. Well, Liam's on his way back. I can almost imagine him walking up to, and Chris. You seem to have lost one of your members. What have you done with Martin?
He's on his way. I can't tell if Alan Jones is sat really still or if his video is frozen.
Well, he should be in the waiting room, but he's not appeared. Ah, right. You should appear now. Ah, you made it.
Yes.
So are you the chairperson of the committee, the judging panel?
I am, yes.
Yeah,
You're ready now, are you? You've done
yes, we've had our little AGM.
Okay.
And we've got them on the committee officially.
All right. Good. Okay, well, thank you very much. I must thank both the speakers, both James and Thomas, two very good, very professional presentations. So well done to both of you. It was very difficult in the judging that we've just done. So I know Tom's introduced the judges, but Liam, as well as working for Ricardo, is here representing the Permanent Way Institution tonight, and Chris Beals was the other judge representing Young Rail Professionals YRP. So we have come up with a winner, because we have to come up with somebody who's actually going to go through and represent the Midlands Centre of the Railway Division at the National Heat. And it was a very close call. So two very, very good presentations. But overall, the winner of tonight's competition and the deciding factor really was, well, I'll announce the winner first. The winner, I'm pleased to say, is James and his presentation about mitigation against ice. So he will go through to represent the Midlands Centre at the national final. So well done, James. And Thomas, very good presentation. The deciding factor in the end that meant that James has gone through was simply the timing of your presentation. There was an awful lot of content in there, and unfortunately we weren't able to get through within the allotted time. So it was purely that. So the content of both presentations was very good, very professional, and you both handled the questions in a very professional way. So it would have been a dead heat, but the deciding factor was just time. So as I think Tom alluded to earlier, there is actually, as well as going through to represent the Midlands Centre in the national final, there is also a prize for the presentations this evening. And the prize money will be awarded as follows, and Tom will be in contact with the two presenters. So James, as the winner, gets £125. And Thomas, as runner-up, gets £75. So if Tom, please, as the organiser of this event, if you can make sure that you get James and Thomas's contact details, because we will need to get the money to them. Clearly, in the olden days, we would have actually given them cash in an envelope in a room, but we're not in that place anymore. So that concludes the competition, and I'd like to thank everybody for asking questions and being the audience, and obviously thank the judges once again for giving up their time, but of course thank the two speakers for giving up their time to prepare the presentations and then deliver them this evening. Okay.
Have you anything to add, Tom? I mean, thank you for your efforts tonight and preparing the speakers to drag them to the podium, so to speak.
Echoing Martin's comments, very, very informative presentations, and I think that the money's been divvied up justly. Yeah, very, very good content from both of them. I say I've got both your details, Tom and James, so I'll be in touch tomorrow morning to figure out how to send that prize over to you, and James' details of the final to follow. If nothing more to be said, I propose we leave. Say thank you all for your attendance, audience as well, much appreciated. I hope you've learned something and taken away something useful from the presentations. I know I have. So yeah, thank you all for attending, and free to leave.
Thank you, Tom. The last word is, as some of you found out by the incorrect link, the next meeting is the 9th of March, which is about high-speed freight locomotives. So I'll get the link right for the email, and look forward to people joining us then. Thanks again.
Thank you.
Thanks all.
Thank you.
Yeah, thanks a lot, everyone.
Thank you for having me.
Thank you.